Hey there, students. We have already done a day of VSEPR, and the whole point of that day was to get you used to those basic steps that are needed to start drawing compounds. We're going to add to those steps today. So this is the second video, the one you should watch on day 2, because we have already gone over the basic steps of drawing. We're going to look today at what to do with charges, what to do with synops elements, and whether or not there's going to be resonance. So I've got some examples here to work with you. And I want to stress I am not changing any of the steps from last time. They are still there. I am adding to them. All right. And so again, the warning, which I've said from the beginning, be sure you don't do your steps out of order. That will not get you to where you need to be. So we're going to start with NH4 plus, and I think you'll see something we haven't looked at before, and that is it has a charge. It has a plus. Okay. When there's a charge, it makes two changes, one at the very, very beginning and one at the very, very ending. Okay. So the one at the very, very beginning comes with the idea of what happened to give it a plus charge to begin with. So NH4 plus means we lost an electron. And if it was a +2, we would know we lost 2. If it was a +3, we'd have lost 3. All right. So that means way over here at the beginning, when I'm totaling my number of electrons, I'm going to have for nitrogen 5, for each hydrogen 1, and I've lost an electron. So here's the first change for when you have a charge. I'm going to subtract 1. All right. So, and that's because a +1 charge means I have 1 less electron. So there we go. So that is 8. When I divide by 2, I get 4 pairs. That's what I'm going to show. So maybe, I don't know, my N in the middle, 4 H's, just like we've done previously. This is nothing different. Okay, the same steps as before apply. I don't put lone pairs around the hydrogens because they're hydrogen. And so now I count my pairs. 1, 2, 3, 4 pairs. With those 4 bonds, I'm done. Here's change number 2. When I'm done with my drawing, because of the charge, I put the whole drawing in brackets with the charge on the outside. Okay. And that's to communicate with others when they see my drawing that somewhere in that drawing is 1 less electron. Now, I will never know, no one will ever know, was it from the hydrogen, was it from a nitrogen? No one will know because all electrons look the same and they're always moving around. So we'd have no way to tell. But I am indicating to get this particular picture, there is 1 less electron than those elements would normally bring. And that's why we put the brackets in the charge. We still look at the electron domain. So 1, 2, 3, 4 domains around nitrogen. Of those 4, 0 are lone pairs. Okay. And you still look that up in your chart and you get tetrahedral there and tetrahedral there. Okay. So you just fill that in from the same chart we used last time. That chart is still the same. When I go to number 2 here, you can see I now have a negative charge. Well, what has happened to get a negative? We have gained electrons. So again, I'm going to count for that when I get started here. So carbon is 4, nitrogen is 5, and then another electron, that gives me 10. Okay, so again, it really is backwards. For a negative charge, you add to your valence electrons. And for a positive charge, you're going to subtract. It's weird, it's backwards. Be careful. 5 pairs in here. Okay. Now, normally I don't personally do 2 atoms because it's really boring. You're going to see why in a minute, but it does illustrate a very good thing that happens here. Okay, so I'm going to call carbon the middle atom, and it's going to be linked to a nitrogen, and it's only those 2 atoms. And as it's the outside atom, my nitrogen is going to get all its lone pairs. Okay, hydrogen did not. Nitrogen does, because anything not hydrogen does. And I count my pairs. 1, 2, 3, 4. I need 1 more pair. And as always, we put the leftovers on the center atom. So there we go. Okay. My drawing looks done, brackets, but here's the thing. My drawing's not done because I want my drawing to match what nature does. And there are 5 elements famous in nature for loving to bond. They love to bond so much, they will absolutely always bond to achieve a minimum of an octet, 8. My carbon right now has 2, 4, not 8. And see how it's in that list, okay? So I call it the synops, kind of like I'm saying cyclops, but it's synops, all right? So we need to give it 8 so that my drawing matches nature. So my drawing is incorrect, is what I'm trying to say. That's okay, let's fix it. To fix it, I'm going to erase a lone pair. Now I would, with pencil, use my eraser, but I'm going to get rid of a lone pair and I would draw another bond. Oh, I just drew a double bond. Does that help carbon? 2, 4, 6. Well, now it has 6. I'm getting closer, but that's not enough, is it? Okay. So now I drop another lone pair. I would erase it if I was using pencil, and I draw a triple bond. So there we go. So 2, 4, 6, 8. 8 octet around the carbon. Now my picture matches what I would find in nature. So now it's good. Okay. These are the 5 elements I expect you to know that do this. Every once in a while, there's another element that kind of in these situations do, and then again in these situations. I'm not going to ask you to know those. I ask you, these 5 always will get at least an octet. Now, again, let me reiterate, none of the steps from last time have changed. So when did I figure out it needs the multiple bond thing? I still did the normal drawing steps from last time. It was only after I was done with all 5 pairs that I asked myself, is the center atom, carbon, one of these elements in the synops? If it is, does it have 8? If it does not, which it didn't, I need to make that happen. So what if I do my drawings, same steps as last time, and I do not have a synops element in the middle? Okay, you're done. What if it doesn't have 8? Okay, you're done. It's these synops elements where you go, hey, synops element, better check if it's 8. Okay, now if it has 10, it's good. If it has 12, it's good, but it needs 8. If it adds below 8 after you're done with your bonding pairs, or all your pairs, sorry, your electron pairs here, then you need to get it 8. Now, this actually, if we looked it up, this is 2 electron domains, because VSEPR doesn't care whether it's a single bond, double bond, triple bond. It's in the same region. It's in the same electron domain. So this is a 2, 1. And if you go to your chart, you're gonna be like, I don't even see a 2, 1. You're right. I never put a 2, 1 on your chart because it's so boring. What's the only shape that 2 atoms can be? Linear. That's it. That's all they can be, linear. There's no other choice. That's why I go with the more interesting ones that start with 3 atoms and put that in the chart because they're just more interesting. Okay. Next up, I still want to show you some more of this. So here we go with some more. I have SiO3. Oh, again, I have a charge, so I'm going to count for that. So silicon's a 4, and each oxygen is a 6. And I have a positive 2, 2 extra electrons with that 2 charge there. So that's 24. I need 12 in my drawing. So maybe a silicon in the middle, some 3 oxygens going on like that. Yes, I do the dots because they are not hydrogen. I mean, the same steps as last time. These are the same steps as last time, nothing different. Now I pause and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 pairs of electrons. There's the words. 12 pairs of electrons. I needed 12. My drawing's done. Oh, wait. Brackets, because it has brackets. Okay. Now, this is where I would normally say, check if it's synops. And you'd be like, well, silicon's not synops, so I'm done. Well, I happen to know that silicon with oxygen like this will actually be synops. Sometimes silicon isn't, sometimes it is. Don't expect you to know that, okay? So just take my word for it. We're gonna treat it that it needs an octet, because that's what it is in this particular compound. So I look at silicon, see it has 2, 4, 6. So far, it needs 8. Okay, gonna get rid of a lone pair, make a bond. Boom. 2, 4, 6, 8. Done. That's 1, 2, 3 regions of electrons, 3 electron domains, 0 of them are lone pairs, and so it's trigonoplanar and trigonoplanar, and you can pull out your chart, fill that in. Here's a question for you. Did it have to be on that oxygen on the left? Was there anything different, special, unique about that oxygen on the left that I double bonded on the left and not on the right or on the bottom? No. Okay, so when there's more than one place a double bond can go. Now, how do I know to do this? When there's a double bond. If then there is more than one place the double bond can go, I need to show all the possibilities. We call this resonance, because in nature has the choice of all these possibilities. We need to show them so that we are being true to nature. That means my silicon could have double bonded to this oxygen instead of the one on the left. Okay. Good thing this is an art class, right? And it also means my silicon could have double bonded down here. These are the 3 possibilities. 3 places the double bond could have gone, 3 possibilities. All of them need the brackets in charge of -2. Okay. We call these resonance structures. We do officially actually put double-sided arrows between them to show that these are resonance structures. It's just our symbol for resonance structures. And that's what we do. Okay, now let me back up. When do I do this? I took care of the charge at the very, very beginning because that's part of the addition of the charge. Then I did the normal steps, all the normal steps from last time. I did those. Then I asked, does silicon have the octet that I know it needs in this case? The answer was no. So I put a double bond and that gave it its octet. Then I asked, okay, so see how these are after I did last time's work? These are additional. Then I asked, is there more than one place that double bond could have gone? Now, so we only ask it with double bonds. With a triple bond, it's not possible. There's no more than one place a triple bond could go. Not going to happen. With a single bond, it's all singles. If I have 2 double bonds side by side, like there's no other place that could go. I only expect resonance if there's a double bond and if it can go more than one spot. If it can go at 3 spots, I'll have 3 pictures. If it can go in 2 spots, I'll have 2 pictures. You won't have a case where it can go in more than 3. So those are the choices. All right. So that is resonance. That comes after synops. Synops is multiple bonds, and that comes after doing the normal steps of last time. And charges make a change at the very, very beginning. I add or subtract. And then charges make a change at the very, very end. I put brackets in charge. All right. Last one, you'll notice this one actually doesn't have a charge. Okay, so I just skipped that step. Again, these are situational today. These are when this case arrives, it won't be all the time. The steps I told you last time, those will be all the time. That's why we spent so much time on those important steps that happen all the time. I'm going to do CH2O. I believe that totals up to 12. If I am wrong, I will find out soon enough, I guess. I need to show 6 pairs. Okay, so I've got like a carbon in the middle. I've got 3 things to attach to it. So I'm going to do something like that. Maybe an H there, an H there, and an O there. Okay. So that's how I'm going to draw it. And I do my lone pairs. Hydrogen does not get them. Oxygen does. There we go. Now I count my pairs. So these are this has been the same steps as last time. 1, 2, 3, 4, 5, 6. Okay. Now that I've did all my steps from last time, now I ask about synops. Is there synops? Yes, there is. Carbon's in the middle. Does it have an octet? No, it does not. It has 2, 4, 6. So it needs 1 more. Am I going to do that with the hydrogen, or the oxygen? Well, I hope you say, well, the hydrogen doesn't even have a lone pair to do it. That's great. What if those weren't hydrogens? What if those were chlorines or fluorines and they did have lone pairs? Okay, let me tell you something. Listen well. The multiple bonds not only happen when the synops element's in the middle, but it will only multiple bond to other Synops elements, which means it has to go to oxygen. There we go. 2, 4, 6, 8, and I'm done. 3 regions of electrons, 1, 2, 3. 0 of them are lone pairs, trigonal, planar. There we go. Okay. And again, we're skipping all these until after we can model, which will be coming in the near future. So don't worry about those. You'll get your assignments back and then you'll fill them in once we've gotten to that point. So again, I want to stress, reiterate, remind you of what I just said. Say I have carbon with 2 chlorines and 1 oxygen like this going on. Well, chlorines are going to have lone pairs. Oxygen's going to have lone pairs. Everything has lone pairs, so can't I double bond to chlorine? No. Again, the only acceptable place to do a multiple bond is between other Synops elements. Okay, so there you go. That's what we added today. This is going to make your work today slower because there's possibly more steps. Let me say it that way. Okay, so it's not 16 problems, it's only 12. Okay, take more time with it. It also means you're probably going to want to be like asking yourself, and preferably in tutorials, asking me, hey, am I doing this right? Am I doing that right? Do take the time, go slow, do well. Again, charges are an addition. They affect the very beginning and the very end. Again, Synops, I only check for it after I've done all the normal steps we did last time. Again, resonance, only if it's a double bond and only if there's more than one place that double bond could have gone. So please understand the progression. I watch so many students get it wrong because they start drawing, they see a Synops in the middle and they decide everything's a triple bond. And then you suddenly are giving a Synops element like 16 pairs. And no, okay? Normal steps as last time. Then ask about Synops, then ask about resonance. All right, so that's what we are up to today. Do practice this well. I know you won't get this right away like you did last time, but if you keep working at it, you will actually get it and be just fine. All students catch on to it. Please come get help in tutorial time if you need it. Good luck on the assignment.